grow, regardless of gender identity, gender expression, race, ability, sexual orientation, and the combination of those identities. There's something for everyone at DSW. Thank you for joining us. Before we kick off, please join me in recognizing our sponsors.
Hi, Denver Startup Week. I'm Ben Data, CEO of Food Maven and co-chair of Denver Startup Week, the largest free entrepreneurial event in the world, and it's only possible thanks to the support of our sponsors. We have nearly 40 sponsor companies who contribute to make DSW possible. Let's show our love for these companies today and all week long. Thanks to our title sponsors, Downtown Denver Partnership, JP Morgan Chase, Prologis, and Xero. Our track sponsors who have made all the great content you're hearing today possible: Battery 621 in the Public Works, Capital One Cafe, Colorado Lending Source, Friday Health, Quizlet, Exactly, Zayo, and Zestful. Our headline event sponsors are bringing you inspiration from around the country. Thank you to Wix, Kenzen, MAPR Agency, Obsidian HR, Kickstart Fund, Promontory Mortgage, Molson Coors, and Comcast. Finally, thank you to our partner and member sponsors listed on the screen. Thank you for your support of Denver Startup Week. Now let's get to it.
Quizlet is a global learning platform that provides engaging study tools to help people practice and master whatever they're learning. Every month, over 50 million people use Quizlet to study any subject imaginable, for school, work, or as part of their personal interests.
Quizlet is super efficient, and I often, walk to class with it on my phone or even just before I go to sleep.
Combining cognitive science and machine learning, Quizlet guides students through adaptive study activities to confidently reach their learning goals. Quizlet has over 200 employees across 3 offices in San Francisco, Denver, and London.
Being at the Denver Quizlet office for the last year has been pretty incredible. Seeing the office grow while maintaining its, core connections to our values. It's been an incredible experience to be a part of, seeing how humble, candid, and open everyone has been, and being part of a mission-driven company in a time of uncertainty has been incredibly rewarding. So I look forward to, what the future brings, because the last year has been a wonderful experience. Thank you, Quizlet.
Hey everyone, my name's Adam Bauman and I'm part of the Quizlet team here in Denver. I'm proud to work for a company that's goal is to help every single person on this earth become a better lifelong learner. One of my favorite things about working at Quizlet is how much we follow our company values. There's always learning opportunities. We encourage everybody to teach themselves something new, as well as help each other learn. Whether it's from art classes or lunch and learn talks on latest technologies, there's always something new to find and help yourself grow. And I really feel like that's one of the best things that any company can offer is growth and opportunity.
Great. Thank you to all of our sponsors for their support in helping us keep DSW free and accessible for all. Now, I'd like to turn things over. We have a pre-recorded video today, which should be excellent around machine learning and bias in machine learning with Ayodele. I'm going to switch it over to the video now for everyone to enjoy. Thanks so much.
Hey everyone, I'm about bias in machine learning. Thank you so much for attending Denver Startup Week, and let's just get right into it. Awesome. So today's topic, combating bias in machine learning. Starting this off, I really just like to provide a good definition for bias. There's a couple definitions for bias in data science that are around activation functions and the bias bias variance trade-off, but I really want to focus on how I'll be referencing bias for the rest of this talk. So I'm going to be focusing on how it's a tendency or an inclination towards or against something. Whether positive or negative, these kinds of biases exist in our society because humans are biased, but they're also cultural and historical artifacts that can end up in our data. First thing to know is that algorithms perpetuate existing prejudices. So these cultural artifacts, like I mentioned, not only are they in our data, but when they're used in automated decision systems, basically using data and vast amounts of it to try and make decisions better than a human would. Unfortunately, what we end up doing is just encoding these biases and then having them make decisions at a really, really large scale. So that's where we start running into these issues around algorithmic accountability and model bias. One of the things I really like to get people started thinking is how you might be systemically marginalized. Not all of us are, but as you'll notice, especially in this top half, a lot of these have to do with geography and not necessarily behavioral attributes. So the first thing we should understand is that we have historical artifacts of the dominant culture and the dominant norms in all kinds of data. And bias is really about marginalization. And there's several nuances to this, including intersectionality. I think something really important for developers to understand is that data is not neutral. Data is subject to the social, political, systemic, and cultural norms that were dominant when it was collected, manipulated, and when it was modeled. Bias is kind of the enemy of equity in machine learning. And in order to fight it, we have to recognize what it is. We have to know that we all have it and work through how society has nurtured us to support the biases that we're accustomed to. Technologists must be willing to be uncomfortable and confront these biases they hold to address how this bias and inequality are outcomes of their machine learning models. So we'll go into types of bias in this next section. So understanding that it's popular in feature selection and it shows up in so many other ways, and there are so many different types of bias. However, I'm just going to go over the three that are the most common in machine learning. So first off is prejudice bias. So imagine you're creating a computer vision system to try and identify different types of careers or photos of different people at work. So if you're just scraping the internet like many people are in computer vision problems, you will probably find a lot more photos of male doctors than female doctors. And you'll probably find a lot more photos of women as nurses and men not as nurses. Basically, this really just happens because those are society's norms. Those are the pictures that are unfortunately good stock photos. It's hard to get good candid photos of these types of things. And unfortunately, by doing a basic image search, this is what you're going to end up with. And it's not that there aren't photos of women as doctors or of men as nurses. It's just that the disparity there is going to be really, really large. So one of the ways to fix this is really to expose your algorithm to a more even distribution of samples. So understanding that several types of roles, several careers are dominated by certain genders, and understanding that you need examples and enough examples in those other classes to really balance out and try and have better predictions. Another really important aspect of bias here is measurement bias. So this happens when there's a bias or a defect really with the device that's used to measure. This is really popular for sensors. Unfortunately, we've seen with the popularity of wearables and smartwatches that a lot of these heart rate monitors are not as good detecting heart rate on someone who has dark skin. So one of the ways to address this is to really widen our pool of products that we're testing and widen the groups of people that we're testing on. A lot of times when we see funnels like this, we think about sales funnels or marketing funnels, but we should start thinking about this in ways to actually widen the groups of people that we are including in this product prototyping and testing. A lot of smart startups and small groups start with people they know, their friends and family. Then they may reach out to larger organizations to try and create some of these focus groups and test products better. But it's very rare that you see people going outside of what they assume their user base would be. So finding people who have dark skin, finding people from other parts of the world with less access to technology in general, and testing these products there as well. And doing that so in an equitable and fair way is really, really important. Lastly, we're going to talk about sample bias. So this happens when the data collected doesn't accurately represent the environment it's going to run in. So unfortunately, this is a really, really common area, and it's a little bit difficult to fix. So sometimes what you have to do is go out and get the data you don't have. So if you are trying to stratify your training data samples to create models that are more similar to what a general user group would look like, it's really difficult to find people who are in some of these smaller cases or in some of these smaller classes. But that's the thing, it's not usually quick, easy, or cheap, but that is the cost of good machine learning. It may be easier in a lot of cases to not use ML tools if you can't get this kind of data. And maybe we step back and understand if this problem even needs a technological solution in the first place. As developers, you have to assume that every model you create will encode racist, sexist, and biased norms unless you address them specifically. And going into the developer's role, and this is where it gets really important. We have a lot of action items on this list, but really going into how we can improve our documentation, model explainability, get up to date with best practices, and then really focusing in on human intervention of these machine learning models, as well as creating equity with the products we build. So that first step in documentation, we should be we should have a bigger focus on reproducibility. And unfortunately, as an industry, we don't. A huge aspect here is our data, how it's collected, how it's been manipulated. And oftentimes, if you're analytical or a data scientist, data kind of comes to you either pre-altered or in a CSV format, and you have to do a lot of work to understand basically that data's historical context, how it's been handled. So one thing that you can implement is data sheets for data sets. This is just a documentation way of creating methodology to document how your data has been altered, the kinds of data that are missing, and all of these things that you might find in doing exploratory data analysis, so that let's say 10 years down the line, this data is still being used for prediction, you're gone and moved on from this role, and someone has to step in and try and make sense of it. So really just getting our documentation up to par with machine learning models and not keeping everything in Jupyter notebooks and being really casual about how we're documenting this, especially in industry. Next is model cards. So this makes it really, really easy to not only talk about and document your model's reproducibility, but really go into taking some steps towards risk mitigation. So the one you see on the screen now is face detection. Google has model cards for their face detection and object detection algorithms. And what's really great is not only do you get to look at the performance of these models, but it really outlines and focuses on the limitations and trade-offs. So this is an area that we don't often like to talk about because sometimes we tie our self-worth into how well our models do. But really, at the end of the day, we need to focus on the limitations of our models and understanding ways that they can be abused, ways that bad actors and people who are malicious would use these models for bad reasons. Really taking the step to document that is really the first step we can take in trying to fight this bias problem in machine learning. Next is model explainability. So there's actually a lot of tools here that are model agnostic or language agnostic, and you can use them across different platforms. So one of my favorites is Lime, and that's interpretable model explanation. So what's really nice about this is you can see why a decision was made. So for the image you see on the screen, this is looking at a data set of mushrooms and trying to decide which ones are edible and which ones are poisonous. In this middle frame, we can see that, you know, only the gill size is the only indicator that this mushroom might be edible. But if we're looking at all of the other features like the odor, the stalk surface, all of the other aspects of it, that leads our model to believe that it's a poisonous mushroom. Having this level of detail and explainability is absolutely huge, not only in providing transparency for your customers and building trust, but at the same time, trying to build in recourse. So build in ways that users, let's say, who have been negatively impacted by your models can actually come and dispute these decisions. And you'll at least be able to say, okay, we have an understanding of why this decision was made. Black box models are no longer acceptable in that we need to be transparent with users about how we use their data to train these models, and also how these models can impact them and impact their experiences with our products. Best practices. So not only should we be using rare cases to benchmark a lot of these decision making or these models, we really need to hold those results to extreme skepticism. So understanding based off of not only protected classes, but all of our subgroups of attributes, so racial, gender, all of those subgroups, understanding how our model performs on each one, understanding if we're accurate for those, or if we have disparate errors for those. That's crucial to creating machine learning models that are fair and that are not biased. And a huge portion that unfortunately we leave out in industry because typically we don't have time, is we need to investigate for bias, especially when we think there isn't any, especially when we're not using gender or race as features. There's so many other features that can be proxies for those, like zip code is often a proxy for race. Weight is often a proxy for gender. So despite removing some of these obvious features, we do need to take further steps to investigate how our machine learning models are biased. Human intervention. So one of the major problems in industry is that we create models and people see outputs of those models as the last and final decision. A lot of times we have this tendency to deflect responsibility on the computer or on the algorithm for an output, when in fact, these outputs should be just one single input into a human's decision-making process. So when we're building these machine learning models, we need to focus on creating human in the loop projects so that not only these models get supervision in how they're trained and a little bit of guidance when they are starting to make some errors, but also we have some utility functions and we have some more solid and more methodological, I can't say this word, methodological autonomous systems. So we really want to not only have more human in the loop systems, but create recourse strategies. Like I mentioned earlier, if someone is denied a credit card, they are able to see, because of the FCRA, the Fair Credit Reporting Act, they are able to get reasons why they're denied for a credit card. But when we're talking about a lot of social and online systems and even government automated systems, there's usually no opportunity for users to dispute these decisions. There's usually no opportunity for them to change aspects about themselves to get a better result, essentially. So we need to build in strategies that not only allow for this recourse, but can inform consumers on what aspects they need to change. So if someone wants to get approved for a loan and maybe they need to have a higher income, we need to understand that these changes people should make need to be realistic. So we can be looking at a credit card application or a loan application, and we do see factors like if they're married or not. Our advice shouldn't be for single people to get married. Our advice might be you need to raise your income by $5,000 a year. And on the other end of that, we can't, because we are trying to change these outcomes, which helps us better understand our models, we can't expect people to change their income by $50,000 a year to get a better outcome on a loan. That's just not realistic. It's not going to happen for the vast majority of people. So understanding that our models are really modeling history, and we're using them to predict the future in ways that maybe they don't make the most sense. And we also need to, as far as human intervention, really change our data science workflows and life cycles against a lot of software engineering practices. So unfortunately, machine learning and AI has kind of been shoved underneath the engineering group when in fact, it is more research and science. And we need to spend more time on the front end of these projects to really understand the societal implications. And that means working with sociologists and social scientists to understand our impacts and how our technology will impact people. The truth is, the vast majority of us are not skilled in this. We don't have an education in bias and fairness and policy. So we really need to rely heavily on our connections to understand how we can change machine learning life cycles to create better and more fair models instead of trying to optimize for increasing the bottom line by whatever means necessary. As far as having a mitigation plan and mitigating this risk, we need to have essentially an algorithm kill switch, a way to turn off an algorithm and a framework to really operate without that ML solution being active. If these solutions are core to your company's products, you should have backup plans. You should have things to accommodate users in the meantime while you are working on improving your models. These are a lot of things that unfortunately companies right now are just not thinking about or implementing. And lastly here, we really need to talk about optimizing for equity. Trying to use algorithms that have typically been biased in the past, like recidivism algorithms, they can be repurposed to do things like defund the police. We need to incentivize equity instead of revenue growth. We have to understand that, yes, there are business features to balance, but at the same time, we can't really expect altruism and we can't expect ethical technology when there's strong business incentives not to be ethical. So one of the resources I really recommend here is the Algorithmic Equity Toolkit. This is a great tool by the ACLU. It can help you identify automated decision systems and on top of that, really discover the potential for abuse. So it comes with a couple different forms you can fill out that help by asking thought-provoking questions so that you are interrogating these systems a little bit more. It also outlines metrics and injustices in these algorithmic systems. So another thing we need to do here is really center equity in our life cycle. So another resource is a toolkit for centering racial equity throughout data integration. This is created by the researchers at the University of Pennsylvania's Actionable Intelligence for Social Policy group. And what it does is it provides advice for reinforcing racial equity at each point through the data life cycle. So in the planning stage, really understanding if we need machine learning and we need advanced tools to do this project. So in that planning stage, we shouldn't just be undertaking projects because we have the funding for them. We should be leveraging, like I mentioned earlier, people in humanities, people in social sciences to understand how else we can solve these problems if we don't need machine learning for them. In data collection, it's really important not to over collect information and be really, really, really strict about how this data is accessed. for data access, it's so important to have strict protocols, because a lot of times we are dealing with PII, or personally identifiable information, and keeping user safety and privacy at the forefront of our minds, and how we actually go through this data life cycle is incredibly important. When we're building algorithms and using these advanced statistical tools, it's really important to focus on really not having black box models, being transparent about how we're using these models and how data drives these algorithms. We should use some of these early warning indicators to really understand how these vulnerable and at-risk groups can be impacted by our algorithms. And lastly, in reporting, it's really, really important to understand that we have to be transparent and open with the general public about these models. We're coming into an age where the public is more knowledgeable. We have a lot of people in tech and tech activists that are educating people about how companies are pretty much being shady and using their data. So we do have to be open about this in pretty much all arenas. That is something that's going to be expected of pretty much any company using machine learning and AI in the future. So rare cases should be your baseline data that you can benchmark against, and not addressed in later versions. This goes back to measurement bias and a lot of issues that we have with sensor data. They don't work on dark skin, or they don't work as well for women, or things like the Apple Health app, they don't have cycle tracking despite women being 51% of Apple's user base. All of these are exclusionary issues that unfortunately come about from a lot of exclusion and bias in the groups that create these products. So really taking that to heart and understanding that the people who look the least like you and have the least in common with you should be the first people you test products on. We also have to understand that development has not been neutral. As much as we would like to think that software and the way technology has evolved has been neutral and accessible for everyone, it hasn't. Things like camera, photography and camera development. What you're seeing on the screen right now are Shirley cards. Cameras were tuned and optimized to make fair skin look good. There is a very specific reason why dark people don't photograph well with most cameras, and that's because the camera hardware that we know now today was tuned for light skin. Development has not been neutral, and technology has not always been made to work for everyone. And just 2 months ago, the ACM actually urged lawmakers to immediately suspend use of facial recognition by businesses and governments. They basically cited that the well-documented ethnic, racial, and gender bias. So what's the basis of this? Camera photography and camera hardware. And that's typically the initial reason why we have this racial and gender bias, but we also have very, very limited training data. And in fact, it's not that we have limited training data, it's that these very popular models and APIs use limited training data and then try to generalize on everyone, but perform really, really badly, especially if you're a woman or if you have dark skin. So you might be asking, how do we create ethical machine learning? There's a lot of questions really for us to ask ourselves here. Really, if the solution matches the problem. I've said this over and over again, and unfortunately, what happens a lot of times in industry is that we think about this and then we go along with the project as planned anyway. We really need to take a step back and say, maybe we shouldn't go forward with these projects if they have a larger chance of creating harm or having really biased outcomes. Next, we have to investigate if we have the right data. And I'll be blunt here, most of us don't. For a lot of the things that we're trying to predict, we do not have the right data, and we're working with proxies or what we think is the closest to the right data. A lot of times, this is really just driven by business need. Our businesses need us to model certain things so they can productize certain models and create revenue. Unfortunately, we have incentives to not really do the right thing here. But another thing we can do to try and fix this is really to examine for and remove bias proxies. Like I mentioned earlier, aspects like zip code and weight aren't protected classes, but a lot of times they're highly, highly, highly correlated with race and gender. So understanding which features that these protected classes are correlated with, and trying to really initially run models without using those as well. We also need to consider who we create models for and whose lives are made easier. This is huge because we unfortunately tend to make products for people who we think are like us, people who are in similar roles or who have experienced similar frustrations. Unfortunately, this doesn't really leave room for us to think about whose lives might be made harder by what we're creating. We also should be testing for bias and developing plans to mitigate this harm. So harm mitigation especially, it's not just about, okay, we feel bad that you had a adverse action or a negative decision, and that's kind of it. It shouldn't just be a rejection email with no feedback in the way ATS systems do. What we need to have really in place is a system so that users can dispute results, as well as developers can really go in and understand why decisions were made. And from there, really investigate if the model made the right decision at that point in time. We need to take further steps, and I do think that's part of the growing pains of being really early in talking about fairness and equity in machine learning right now. We also need to pay more attention to modeling or monitoring our model predictions. So understanding if we're predicting well across different protected classes, as well as giving our models feedback. This is one of the biggest criticisms of crime models specifically, in that they're hardly ever given feedback about what actually happened. So not being able to have, essentially, you can think about it like back propagation, not being able to have that information about where the model was wrong really just lets us spit out and regurgitate history. We're not really making predictions, but we're just amplifying at different intervals things that have happened already in the past. For further reading, I have a list of books up here that I absolutely love and really recommend. That last one, Automating Inequality, is by Virginia Eubanks. These are all books that have formed the basis of really my knowledge and bias in machine learning, and has kind of, that's basically fueled my passion in trying to discover this and help developers learn how to fight it. More from me. So I have a couple books coming out this year. Well, one book coming out this year, one next year. Getting Started in Data Science is my ebook that is going to be coming out October 20th. I'm really excited. It is really geared towards newbies and includes a chapter on bias and fairness and accountability. And my book, Uncovering Bias in Machine Learning, will be out next fall. Excuse me. I'm really, really, really excited about both of these books. Uncovering Bias in Machine Learning is my passion project. I will be dissecting and giving information for developers on how to fix these problems with code examples and frameworks to talk to management and talk management out of using certain machine learning tools for specific projects. So if you'd like to connect with me, feel free to reach out on Twitter or Instagram at DataSciBay. Thank you so much. This has been a blast.
Great. Thank you to everybody for attending. We've got some other great content coming up, including an awesome panel discussion on how money works and a discussion with the VP of Engineering from Twitter this afternoon. Looking forward to seeing you all online later.